I would like to invite Varun, who is the head of DevOps and IT and CloudSEK. Please give a huge round of applause for the last session of the day. Varun KM on the stage.
Yeah, thank you so much for staying back for this last session. I'll be as quick as possible, and I will be building upon what Aparna was mentioning about scalability and high availability. Because I'll start from introducing myself. So I head the DevOps and IT at CloudSEK, and we run 72% of all our workloads on spot instances. And this in turn is saving us about more than 100K USD per month, right? I'll get to what we are doing first so that you have context. So what we do is basically scan for client assets, be it for a domain name or a keyword, code repository leak, credential leak, and a lot of different things, right? So these, what do you see at the leftmost column, are all our data sources, and what do they amount to, right? So we have mainly two products, XVigil and BVigil. XVigil is cyber threat on brand monitoring, phishing, and so on. BVigil is on the infrastructure scanning, right? And yeah, this is what we do. Every day we process more than 150 million pages crawl across the web. And BVigil, where we scan for assets, we do more than 100 million assets, and in total more than 100 billion port scans every single day. And for our clients, 24 hours is the SLA. So within 24 hours, this is what we need to do, right? And all of this amounts to a huge number of data. But then our platform, it again filters down to 95. It filters down to the last 5% that actually matters, right? So now, if you think about this scale is humongous, okay? And where we do it and how we do it is what I do at CloudSEK. These are what I would love to build upon what Aparna was mentioning in the last session. So layered caching is very important, without which you cannot scale this much. Event-driven scaling is again a very important concept, which I will talk about. Consumer identity is basically there's a producer and a consumer. Producer produces messages, consumer consumes the messages, right? So I'm talking about the consumer part of it. And yeah, so 90% of CloudSEK follows the same architecture. So this is what I mean by layered architecture, right? So Aparna was mentioning about databases and its high availability. So that's what we are also doing, where we have a primary database and its replica. Upon that, we have Valkey. Valkey is same like Redis, and that's an in-memory cache, right? So that's why it's very fast. And above that, in the pod level as well, we have in-pod caching that again reduces your time taken for response. And then comes your website or web application caching on your laptops itself, right? And because of these layered caching, you're reducing the load on databases, and you're also improving the user interface or user interaction. And pod level caching is even more important when you're talking about service-to-service architecture. So this is what we do on the architecture level, right? So we have two products, right? XVigil and BVigil, and we use message queues like SQS, Kafka, and RabbitMQ. And based on the messages that come into the queues, let's say you have one message or you have 100 million messages, right? Based on the number of messages that come in, we use a KEDA. KEDA is Kubernetes event-driven architecture, and that in turn scales our consumer pods. So if there's no messages in SQS, there's no pods in Kubernetes. That saves the cost. And if there are messages on any point of time, that increases the number of pods. So again, here comes the idempotency issue. If you're not handling what happens when a consumer goes up or goes down, that's when it causes issues on your database, if it's writing something or if it's reading something, because KEDA will not see if the consumer is finished its process or not. It will only see if the messages are present or not. So we have multiple ways to prevent that, but this is not the talk for it. Next time. So yeah, so this is what we are at. This is the scale we are at. 30K pods every single day, 2.5K nodes split across multiple clouds. We use AWS, GCP, Azure, Alibaba Cloud, DigitalOcean, Linode, and so on. We are 4 DevOps engineers who's handling all this scale with the inclusion of CastAI. Why Cast? Yeah, so we have one K8 specialist, and because of Cast, we can use one template, one autoscaler, and do the same thing again and again, multi-cloud. Yeah, so 30% cost reduction as well. I'm sorry for rushing this because it's already 5:30 and I'm trying to keep it as simple as possible. Yeah, and what we learned over the time of handling the scale is if you have response time below 1 second, that really matters when you're talking about service to service. It should actually be between 100 milliseconds to 200 milliseconds. That's the sweet spot. Item dependency I already told about. Choose your data sync. So data sync doesn't mean you use every database as a data sync. So you do your processing on one database. You choose appropriate data sync like Elasticsearch or S3 or Data Lakehouse and so on. That's where you actually store your long-term data. Do not use every database as your data sync. Use managed services that act as buffers. So you never know when you're talking about this scale. You never know when the services spike. So all of a sudden you receive 200 million, 300 million messages in a single hour. That's when you need something like SQS. Metric dashboards for network latency is very important because you're talking about multi-cloud and you never know when, if some network goes down, it becomes a problem. Yeah, this is me. Thank you so much. If you have any questions or anything, please do reach out to me here. I would have loved to take in some more time and explain to you, step by step, but yeah, I think this is a good time. Thank you so much.